Alright, so let's do a couple of examples of simplifying factorial expressions. So the first one we'll use numerical values. So this one here is 12 factorial over 10 factorial. So one way that you could simplify factorial expressions is to expand each term individually. So 12 factorial would be 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. The other one would be 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay? So what I would notice, hopefully then, is that I've got 10 on top in the numerator and 10 in the denominator, so they can cancel each other off because 10 divided by 10 is 1. Similarly, 9 and 9 can cancel, 8 and 8 can cancel, 7 and 7, so you'll notice that everything else cancels out, leaving us with just the 12 times 11, which would give us our answer, right? So you'll be able to see, typically, that something's going to be able to cancel off, leaving you with something much easier to evaluate. Okay? So that's the first method. The second method would actually be to say, okay, I'm going to take my starting point, so 12 and 10. I am only going to expand the larger number until I reach the smaller number. So what I mean by that is I would write 12 factorial as 12 times 11 times 10. I'm going to stop here and just write a factorial sign, so then I can see that 10 factorial cancels with 10 factorial here, still leaving me with the same 12 times 11, right? Okay? So those are two methods that you can use to simplify factorial expressions. Now, that's doing a numerical example, but sometimes they'll give you algebraic expressions like this. So n plus 1 factorial over n minus 1 factorial. You've got a couple ways that you could do this, again, using either of the two methods we did before. Let's use the first one first, just to get an idea of what's happening. So n plus 1 factorial, well, remember, the definition of anything factorial, well, would be whatever it is, you keep multiplying down until you get to 1, right? So the first term would be whatever that is, right? So whatever's in this cloud here, factorial, is the first term that you're multiplying. The second term here would be whatever's in that cloud and 1 less, okay? The next term would be whatever's in the cloud, but 1 less than the previous one. So this is cloud minus 1. So 1 less than cloud minus 2 would be, 1 less than cloud minus 1 would be cloud minus 2. The next term would be 1 less than cloud minus 2, which was cloud minus 3. Okay? So that's just how factorials generally work. And this continues. Since we don't know what this number is, we don't know how long this pattern continues, but we do know that however long it continues, I will eventually get down to 4 times 3 times 2 times 1, right? So I could think, alright, let's say if I've got 99 factorial, well, I'm not going to write all of that, but I know that the first term is 99, right? The second term would be 99 minus 1, which is 98. The next term would be 99 minus 2, which is 97. 99 minus 3 is next. And this would continue on. Since we do know that number, we know how long it continues, and we know that the last three digits would be 3 times 2 times 1, right? Okay? So now, if we look at this example here, we're going to be writing those algebraic expressions using the factorial notation. We're going to expand them, actually. So n plus 1 factorial, my first term, remember, is always the exact same as whatever's inside the cloud here. The cloud has n plus 1 in it, so the first term is n plus 1. Okay? Now each successive term after that is 1 less than the previous. So if I've got n plus 1, the next term here is going to be 1 less than n plus 1. So n plus 1 minus 1. Okay? course, 1 minus 1 here is 0, so this really just simplifies to n. So my next term is just n. Alright, the term after that, well, it would be 1 less than n. Well, 1 less than n is just n minus 1. The term after that is 1 less than n minus 1, which would be n minus 2. The term after that would be 1 less than n minus 2, which is n minus 3. And this is going to continue for as long as it needs to, right? We do know that eventually it'll just get to 3 times 2 times 1. Okay? Over, now I break down n minus 1 factorial. My first term is, of course, going to be n minus 1. My second term is then going to be 1 less than that previous term. So n minus 1, the next term is going to be 1 less than n minus 1, which would be n minus 2. Okay? The term after that again is 1 less, which would be n minus 3. And then the pattern continues until we reach 3 times 2 times 1. When you have it written in this form, then you can see more explicitly that the n minus 1s cancel off right here. N minus 1 cancels with n minus 1. N minus 2 cancels with n minus 2. N minus 3 cancels with n minus 3. 3 cancels with 3, 2 cancels with 2, etc. Everything after this n minus 1 here is going to cancel off. Okay? So that's going to leave us with just, in the numerator, n plus 1 times n, right? So I can have this written like that. Then, just to simplify it, then I would multiply that out using the distributive property. So n times n gives me n squared, plus n times 1, which is n. So I can say that n plus 1 factorial over n minus 1 factorial simplifies to n squared plus n.